Chapter 39, factoring trinomials. We call that a polynomial and so on. Well, we've seen that before. Make sure you always look for the greatest common factor as your first step in factoring. And then we are looking for two numbers in order to start factoring. We deal with trinomials in the form of ax squared plus bx plus c. And I guess we are looking for two numbers m and n, such that ax minus m times ax minus n is ax squared plus bx plus c. Here is an explanation why this works. We are interested in m plus n being b, and the product of m times n being a times c. It says negative b, it could be negative b, it could be b, it doesn't matter. This is a proof of what we are looking for, and this came from this particular site. Follow that link and you will get what we have done here. So to cut it short, I'm looking for a product which is a times c, a sum which is b. Two numbers whose product is like that, whose sum is like this. Before embarking on the algorithm to decide what the signs of m and n are. Now there are four possible cases, and it's very important that you get this correctly. The product can be positive when the sum is positive or negative. The product can be negative when the sum is negative or positive. The first thing you ought to remember is that the sign of the sum is the sign of the large number on the right, small number on the left, just by convention. So the sign of the sign of the sum is the sign of the large number, and the sum is b. If the sum is negative, the large number is negative. If the sum is positive, the large number is positive. What is the sign of the small number if the product is positive? A positive number times a positive number is positive. A negative number times a negative number is positive. A negative number times a positive number is negative. A positive number times a negative number is negative. Get it? You fill in the sign of the question mark. You know if the small number is positive or negative. You know if the large number is positive or negative. And then you continue. Okay? Case 1, I just went over that. Case 2, I went over that. Case 3, case 4. Now that we know the signs of the two numbers we seek, systematically work with the divisors or factors of the product starting with 1. The small number will be 1, 2 if applicable, 3, 4, and so on. Divisibility tests come in handy. Do you remember your divisibility tests? If the last digit of a number is 0, 2, 4, 6, or 8, you can divide the number by 2. If the sum of the digits is divisible by 3, you can divide the original number by 3. If the number ends in 5 or 0, you can divide by 5. 7, I don't have a good algorithm, so if I need to, I'll take my calculator, I'll divide, I'll see if there's a remainder. 9, the sum of the digits again is divisible by 9. 11, there's a special trick, and so on. 13, 17, 19, 23, and so on. I use a calculator. Some students are good at factoring trinomials by inspection. If you are one of these students, you may think you can skip the development presented here. If you do, how can you convince someone else that a particular trinomial cannot be factored? So I suggest you still do it my way, Because if a trinomial cannot be factored, you may scratch your hair for 3 weeks and look for the numbers that don't exist. But you use the algorithm that I show you right now, and it will be beyond a shadow of a doubt that a particular trinomial cannot be factored. If the coefficient is 1, 1 times x squared plus bx plus c, the procedure outlined here can still be applied. If the numbers are small, factorization may be obtained by inspection. See example 7 below.